Somewhere behind the glare of the sun tonight, there's a visitor moving through our solar system that has no business being here and no way of ever coming back. It arrived from outside the boundary of everything we call home, traveling faster than any object humans have ever tracked crossing this neighborhood. When scientists finally got a good look at what it was made of, several of them used the same word in their published papers. Puzzling? Not once, repeatedly. This is the story of what the James Webb Space Telescope found when it turned its mirrors toward a comet that shouldn't chemically make sense. Before we get into it, if you're new here, this channel covers space and astronomy stories the way working scientists actually talk about them, without the exaggeration. If that sounds like your kind of channel, the subscribe button is right there, and it genuinely helps this content reach more people who care about getting the science right. The story starts on July 1st, 2025, at a modest observatory in Rio Hurtado, Chile, called ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, whose job is to scan the sky for anything heading toward Earth. That night, it caught a faint point of light that didn't match anything in its catalog. Within days, astronomers confirmed the orbit was hyperbolic, a wide-open arc that only makes sense if something came from outside the sun's gravity entirely. It was named 3I Atlas. The letter I stands for interstellar, and the number 3 meant it was the third such object ever confirmed, after the cigar-shaped Oumuamua in 2017 and the more ordinary-looking Borisov in 2019. Later analysis of older sky survey images found faint traces of the object going back 55 days before its official discovery, sitting unnoticed until someone knew what to look for. At the moment it was found, 3I Atlas was already moving at roughly 137,000 Doppler-amperes, still well outside Jupiter's orbit. Speed that told researchers this wasn't a local object, since solar system comets don't arrive already moving that fast from that far out. By October 2025, its orbital eccentricity came out to roughly 6.1, more extreme than either Oumuamua or Borisov, the least bound, most aggressive path of the three. Each prior visitor was different. Oumuamua tumbled in a way suggesting an elongated cigar-like shape, showed no visible coma, and displayed a faint acceleration that couldn't be fully explained by gravity, while Borisov behaved much more like an ordinary comet with expected chemistry. 3I Atlas doesn't fit either template, an obvious active coma like Borisov, but a chemical fingerprint, an age in an entirely different category. The first real discovery beat came 7 weeks later when NASA turned Hubble toward the object on August 20th, 2025. Hubble couldn't see the solid nucleus directly through the fuzzy coma surrounding it, but by modeling that glow, astronomers bounded its size at somewhere between 440 meters and 5.6 kilometers, an enormous range, reflecting how little prior data existed. Then came the second beat, where things started to genuinely surprise researchers. As 3I Atlas warmed near the sun, both James Webb and NASA's newer SphereX mission examined the gases pouring off it. You'd expect water vapor to dominate a solar system comet's outgassing. That's not what these instruments found. The coma was roughly 95% carbon dioxide, with water only a small fraction. Webb also picked up tiny water ice particles and carbon monoxide mixed in. A CO2-dominated coma at this distance is unusual, suggesting formation somewhere extremely cold, in a stellar disk region where carbon dioxide ice survives more easily than water ice. Researchers who published this as a preprint in late August 2025 described it as evidence of a very different formation environment than our solar neighborhood. SphereX followed up in September, confirming organic molecules too. The third beat is where the age came into focus, taking almost a year to nail down. Early estimates suggested an age around 7 billion years, already older than our solar system. Real confirmation came from Webb's near-infrared spectrograph in August 2025, and mid-infrared observations in December, after the comet swung past the sun. Researchers led by Martin Cordner at NASA's Goddard Space Flight Center measured the ratio of carbon-12 to the heavier isotope carbon-13, a balance that shifts gradually over cosmic time as generations of massive stars enrich the galaxy. They found far less carbon-13 than anything measured in our solar system, and working backward through galactic chemistry models, concluded the object likely accreted its ice between 10 and 12 billion years ago during an intensely active early period of star formation called cosmic noon. Our solar system is about 4.6 billion years old, and the universe about 13.8 billion. This comet may have been drifting through space longer than the sun has existed. The team published these results in Nature in June 2026, and Cordner called it possibly the oldest object ever observed passing through our solar system. Webb also found the ratio of deuterium to ordinary hydrogen in the comet's water significantly higher than typical, with some analyses putting the enrichment at roughly an order of magnitude greater, a signature that forms in environments colder than about minus 243 degrees Celsius. Combined with the carbon data, it paints a consistent picture. An object formed somewhere unusually frigid and ancient, in a region current models associate with the galactic thick disk, an older, more scattered stellar population than our sun's disk. That's already a lot to take in. But the fourth beat is what pulled 3i Atlas into mainstream headlines. In October 2025, a team using the UVSS spectrograph on the European Very Large Telescope in Chile detected a plume of nickel gas in the coma, later corroborated by Hawaii's Keck-2 telescope. Nickel vapor alone isn't shocking. It's been seen in a handful of solar system comets, including Borisov. What made this different was what was missing. Nickel vapor is normally accompanied by iron vapor, since the two metals are forged together inside dying stars. In 3i Atlas, the nickel signal was strong, and the iron signal was nearly absent. Astronomers scrambled to explain it. Comets are generally too cold for solid. Metal grains to sublimate directly into gas, so something had to release the nickel through a different pathway, likely a molecule breaking apart more easily under sunlight than whatever holds the iron in place. A known process involving compounds called nickel carbonyls could explain low-temperature nickel release without iron, and most astronomers consider it the most likely explanation, though it hadn't been fully confirmed, and several papers described the detection as extremely puzzling. Faint traces of this pattern, though less pronounced, were also spotted in Borisov, suggesting a broader feature of comets formed outside our solar system. Harvard theoretical physicist Avi Loeb, known for his search for signs of extraterrestrial technology, pointed out that nickel without iron is otherwise mainly associated with industrial refining on Earth, and raised the possibility this could indicate something artificial, also citing the comet's trajectory close to the planet's orbital plane. This is a minority position. The overwhelming majority of astronomers favor natural, chemical explanations rooted in its unusual, ancient, extremely cold formation. But the anomaly itself remains real and not fully explained down to the exact molecule, which is why this story kept generating headlines through late 2025. Scientists also pointed the Allen Telescope Array, built to search for signals from extraterrestrial technology, directly at 3i Atlas, scanning radio frequencies for anything indicating an artificial transmitter. This wasn't a fringe stunt, but a peer-reviewed techno-signature search, and the result was a clean non-detection. No artificial signal at any frequency the array could monitor. The fifth beat concerns the comet's physical shape and mass, early. Observations noted it wasn't developing the long-tail sunlight pressure typically pushes off an active comet, sparking speculation about an unusually massive nucleus, with early estimates north of 33 billion tons, dramatically heavier than Borisov. Once, astronomers separated the nucleus's glow from the comas in Hubble images taken across multiple visits in late 2025, and early 2026, they arrived at a refined diameter of approximately 2.6 kilometers, notably bigger than Borisov, though the more extreme mass claims weren't supported. This comet also got closer scrutiny than either prior interstellar object. On October 3, 2025, during its closest approach to Mars, it passed within about 29 million kilometers, close enough for NASA's Perseverance rover and multiple orbiters to capture images, the closest any spacecraft had ever gotten to an interstellar object. ESA's JUICE spacecraft, en route to Jupiter's moons, also attempted observations, and Gemini North in Hawaii captured a detailed image on November 26, 2025. Every comet in our solar system formed from the same disk that built the planets, so studying them mainly tells us about our own local chemistry. 3i Atlas is different. Material that condensed around a completely different star under different conditions at a different point in the galaxy's history. That gives researchers a direct chemical comparison point to test whether building icy bodies works the same way everywhere in the galaxy. The nickel-iron anomaly is forcing scientists to reconsider assumptions about how metals get locked into or released from ice at extreme distances from any star, assumptions built almost entirely on solar system comets. This isn't a discovery that rewrites physics. It's astronomers' first real outside data point. As for the timeline, perihelion came on October 29, 2025, about 203 million kilometers from the Sun, just inside Mars' orbit, speed peaking around 246,000 km/h. It passed near Venus on November 3rd and made its closest approach to Earth on December 19, 2025, at about 270 million kilometers, roughly 1.8 times the Earth-Sun. Distance. NASA and ESA have both been explicit. 3i Atlas posed no threat of impact at any stage. It continued outward, passing near Jupiter on March 16, 2026. Webb has kept revisiting it as it recedes, and in a study released around June 2026, researchers reported the telescope's first mid-infrared chemical fingerprint of methane on the object. For a stretch in late October 2025, it vanished from view, lining up directly behind the sun in a solar conjunction that made ground observation impossible, before re-emerging in early December 2025. If you've stuck around this long, you know this isn't the kind of story with a tidy villain or countdown clock, and I'd rather tell it straight than dress it up. What's coming next is more observation, not more danger. As 3I Atlas continues outbound, growing fainter every month, astronomers expect it to become effectively unobservable to most current instruments before long, permanently. Its material accreted so long ago, and it's been drifting between stars for billions of years, that it's essentially impossible to trace back to its original parent star, which may not even exist anymore. This won't be the last of its kind. The newly operational Vera Rubin Observatory in Chile, with the largest camera ever built attached to a telescope designed for wide, fast sky surveys, is expected to find many more interstellar objects in coming years, possibly dozens over the coming decade. Some are already unofficially calling whichever one turns up next 4I. Unlike Atlas, built to hunt asteroids that might threaten Earth and finding this comet only as a byproduct, Rubin's strategy is designed to scan enormous swaths of sky repeatedly, dramatically increasing the odds of catching a fast-moving interstellar object early enough to study before it's gone. Researchers increasingly believe objects like these have been drifting past the sun since the solar system's earliest days. We simply lacked the technology to notice until the last decade. Here's something worth sitting with before we close out. Right now, 3I Atlas is somewhere past Jupiter's orbit, moving away at more than 60 kilometers a second, carrying chemistry locked into ice before our sun had even finished forming. It will never slow down, never turn around, and never pass this way again. Every instrument that's ever going to study it up close has already had its turn. What's left behind is a full data set sitting in the archives of Hubble, Webb, and a dozen ground-based observatories, a record of a piece of the galaxy that drifted close enough for us to measure once before disappearing for good. When the last telescope loses track of it, it won't be an ending so much as a handoff. The comet keeps moving, carrying its 12 billion years of history back into the dark it came from, while the data it left behind keeps getting studied for years after. Somewhere out there, a fourth interstellar object is already inbound. And right now, tonight, nobody on Earth knows it yet. If this kind of deep dive into real, sourced space science is what you come here for, subscribing helps a lot. Dropping your thoughts on the nickel anomaly in the comments genuinely shapes what we cover next, and sharing this with someone who'd get a kick out of it is the easiest way to support the channel.